Assalamualaikum and hi everyone. Let's continue our regression analysis using the Microsoft Excel. The first part of the video, I'm going to show you how to compute the least square regression lines using the formula. And actually after this, we will go to the second step, how to plot, and from the plot itself, we will have the regression equation from the data analysis, so you don't need to do this manually. Okay, but I'll show you the method on finding all the variables, the variance and the covariance. How can we come up with this regression line equation? Y hat equals to beta naught plus beta 1x. Okay, we have an example here. A warehouse manager of a company dealing in large quantities of steel cable needs to be able to estimate how much cable is left on his partially used drum. A random sample of 12 partially used drum is taken, and each drum is weighed and the corresponding length of the cable measured. So from the statement, we have a data set with n equals to 12. Okay, so we have 12 data here. And first of all, we need to identify what type of data that we have here. Here that already stated that the weight of the cable is the dependent variable and y is the independent variable. So this is important for you to be able to identify which is controlled and which is the variable measured. And the question asks you to find the least square regression line to form y equals to mx plus c, which is here we have y hat equals to beta naught n plus beta 1x. And to find beta naught and beta 1, here is the formula. Okay, so based on these four formulas, SXY, SSX, we can get beta 1 and beta naught. So we have x, y, and here we will put the variables x times y, and here we put the x squared. Okay, all right, so it's quite small. Make it bigger. Okay, so to have x times y, put equal, then you just select this row, star this row, and then enter, and then you just drag all the way to the bottom. Okay, and for the x squared, just type equals and then select the x column, and then we put this hat symbol and 2. There you go, you have x squared, and then you just drag to the bottom. And then you also need the sum values, so just type sum and then select this sum, double click, and just select all the column for x and then enter. Then from here you can just drag for the rest of the column here. Okay, all right, now that we already have, let's try to make it bigger so that you can see. Okay, now that I think we have the component that we want. Okay, now we can compute the SX. So let's move this to the side. We have SXX, SXY, beta 1 and beta 9. Okay. Okay. To calculate the SXX, okay. So the summation of X squared. So mula-mula kita select summation of X squared. So yang ni. Okay. So summation of X, which is there. So we need kurungan kat sini. I think it should be double kurungan. Gonna have square and then over n equals to 12 in this case. Then tutup kurungan. Okay. So there you go. That's a value for your SXX. And then for SXY, summation of X darab dengan Y. So it's here. Okay. Minus. So we need double kurungan. Summation of X is here. Darab star. Summation of Y. Okay, tutup kurungan. Bahagi 12 divided by 12. Tutup kurungan. Okay, there you go, you have your SXY. Beta 1 is simply just SXY divided by SXX. Okay, you got 3. Your beta naught is equals to Y bar is the average for Y. So to find the average for Y, you just type in average. Here is the average. Then you click, double click. Then you select this Y. And then enter. Oops. No. Then minus B1. Here B1. Times the average. So here double click average. X bar. Okay. And then enter. Oops. Yes. Okay. So we have beta 1, 3. So beta naught is negative 20. Here is Y hat equals to 3x minus 20. Okay. So this is the regression line equation from the calculation using the least square method. Next is to plot this data and then to get the regression line equation from the plot. Okay, now we select this X and Y and then select chart here and scatter. There you go. You have the complete graph here. Okay. Alright. So let me just change this to cable length. And then for X we have drum weight. Okay, in kilogram. Alright. Okay. From this scatter plot, we can find the regression line. Go to here. Okay. You check the trend line here. There you go. See this? Let me just make it more change the outline, this, the weight, so make it more tebalkan dia, and the dashes line maybe you can just use this one. So from this regression line we can get the regression equation. Okay, here. Okay, format trend line, and then what you need to do is to check on the display equation on chart, and also you can display the R squared value on chart. Okay, then there you go. Now we have the regression line equation and also the R squared value. You can see that we have y equals to 3x and minus 20. So it's the same equation that we get from the least square method that we've computed just now. Alright, that's the first part of the regression analysis using the least square method and the plot from the Excel. Now that we have the regression line equation, we can use this regression line equation to predict the cable length on drums whose weights are, the first one is 35 kilogram, 85 and 100. To do this, we will use the equation, and then we want to predict the y value, right? So we control the x values, and then we just replace into the equation and we get the y value. Okay, now let's say we have y35, y85 kilogram, y value for 100 kilogram. Okay, so what we're gonna do is just equals to 3 times 35 minus 20. Okay, so there you go. We can predict that the weight for the 35 kilogram is gonna be around 85, so in between 70 to 90. Okay, so for 85 is gonna be the same thing. I'm just gonna drag this to 100. I'll change the value of x here. Then the answer is 235, and this x here is 100 kilogram. So here is the answer that we predict. Okay, so for y85, so 85 is not in the chart, but based on this regression line we can predict that it's gonna be the length of the cable is gonna be 235, and for 100 the length of the cable would be 280 meters.